This is just one last shade norm question just to see if we know what we're doing. The weight of a newborn infant is normally distributed with a mean of 7.5 pounds, which is 120 ounces, and a standard deviation of 21 ounces. If a newborn baby is selected at random, what is the percent chance to one decimal place that the infant weighs less than 4 pounds 15 ounces? Now, do you want to operate in pounds and ounces, or do you want to operate in one unit only? One unit only. So in other words, ignore everything that has to do with pounds. Right? Okay. So what is my mean? 120 ounces. Right? Normally distributed with a mean of 120 ounces. Standard deviation is 21. What is the percent chance that the infant weighs less than 4 pounds 15 ounces or 79 ounces? So the 79 ounces is my raw score, my X. And I want to know what's the percent chance that the baby weighs less than 79, which I would point out is way below average, isn't it? Average is 120. Okay, I'll give you about 2 minutes. That's all you should really need. All right. I got a couple people, 4 out of 6 have answered. Let's have a look here. So I've given you the mean, I've given you the standard deviation. The raw score is 79. It's less than 79. So I mean, even if you just draw the picture, right? We got 120. Less than 79 is going to be over there, right? So it's going to be a small number. Step number 1, convert it to z-score. X minus mu all over sigma. So that's going to be 79 minus 120 all over 21, which is, I guess I should have had my calculator up and running instead of having to wait here. Divided by 21. Did you get minus 1.95? Minus 1.95 is the z-score. And so now you're going to go shade norm. Now, we're going this z-score is minus 1.95. What's the left boundary of the shaded region? Way out here. Minus 5. It's always the left boundary first. Always. Okay, so we're going to shade norm from minus 5 to minus 1.95. And Devin, what'd you get? 2.5%? Oh, 2.5%. Let's just see what the answer is here. 2.6 if you round it correctly. Apparently, according to this. I got 1. Let me see, what do we get here? I got a 2.3, I got a 2.5, a 2.5, and a 2.9. Okay, so the 2.5s would probably be right. Okay, but now I did notice also when you guys did that little hand-in assignment, almost everybody forgot to write out the shade norm step. If you write that out and you make a mistake, then I can give you marks for this. Okay, so please write out shade norm. What's your shade norming? Guys, you need to pick up one of each of those 3 piles there at the front table. Okay, so that's the review part. Here's what I need to talk about today, because I do need to go to this meeting. I'd like to talk to you about invert norm today. Okay? Invert norm is the opposite to shade norm. Okay. So I don't think you have a sheet for this. You can maybe write on the back of something if you want. Invert norm finds the raw score, the mean, or the standard deviation. So if you're given a question that looks like a shade norm kind of question, but they give you the percent and they ask for the raw score or the mean or the standard deviation, then you use invert norm. Okay? Shade norm is given some z-score or a raw score, find the percent or the chance. So if the question talks about the chance of something being less than or greater than, you're going to use shade norm, just like this one did here, right? It said, if a newborn baby is selected at random, what is the percent chance that the infant weighs less than 79 ounces? That's a shade norm. It's asking for the percent chance. Okay? Invert norm is the opposite. And yes, I'm going to show you an example. Invert norm is given a certain percent, find the cutoff, find the raw score, find the z-score for that particular percent. Okay? And I will give you an example. But that's kind of an important difference. Invert norm is the opposite to shade norm. And I can tell just by the looks on your faces that that really doesn't make any sense to you. But that's okay. It's the it's the cutoff. What it does is, like shade norm, maybe I'll draw a picture for you. Shade norm works like this. They give you a z-score, and they say, they're asking you for what percent is shaded. That's what they're asking you, right? Invert norm is the opposite. Invert norm gives you a shaded region, like say 40%, and it asks, what is the z-score? What is the cutoff that cuts off 40%? Where do I cut off to get 40%? Sort of. In fact, pretty much exactly backwards. Okay, so let's just try to figure out what invert norm does. So get your graphing calculator, and I want you to see if you can find invert norm and go invert norm 0.84. Okay, the invert norm is under second function distribution. Now make sure it's not invert t, it's the third one, invert norm. Okay, because it's a normal distribution. So invert norm 0.84. Invert norm 0.84 is 0.99. The heck does that mean? Right? Like, does that tell me anything? Well, not quite yet. So invert norm 0.84 means if I was given a bell curve and I was to shade 84% from the left, how far would I have to go?
Where is that question?
You don't have it anywhere. You're just going to have to jot it down. Sorry. I'll pause for a second. So invert norm 0.84 gives me a 0.994. So what it's really saying is this. I'm going to start shading from the left. Always, 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 always shade from the left. And I'm going to keep shading until I've shaded 84%. This value here is a percent shaded. So I'm going to keep shading until I get 84%. Now, would it be about there? Would that be 84%? How far would I have to go, Luke, to get to 84%? Or how far at least do I have to go? Well, would I be to the left of half or would I be to the right of half? Clearly to the right, because half is what percent? 50%. I need to shade 84%. So I'm going to keep shading until I get about 84%. What do you say, about there or so? Roughly? Something like that? Okay. Guess what z-score this is? I'll give you a hint. It's 0.994. So invert norm gives you the z-score that you would use to shade from the bottom and get the value in the brackets. Okay, so invert norm 0.84. Keep shading until the shading area gets to 84%. Stop. Look at the z-score. It's 0.994. Okay, it's the opposite. It's the opposite. So invert norm gives the z-score that would give the percent to the left of that z-score. Does that make sense? Invert norm gives the z-score, the 0.994, that gives the percent, 84%, to the left of that z-score. I'll give you another one here. Or actually, let me see what's on the next page. Yeah, here's two more to try. Okay, so we've drawn this picture here. This shows 84% in red. My cutoff is 0.994 z-score. Okay, try this one. Try invert norm 16. What happens when you go invert norm 16? Not 0.16, but invert norm 16. Does it work?
No.
No. And it shouldn't work. Because when you go invert norm 16, is that a percent? No, you get an error. How come? Because the number inside the bracket has to be less than 1, because it's 100%. Exactly. Okay? So that one is going to give you, this is going to give you an error, a domain error, right? Number in the bracket number must be less than 1. It has to be a percent, like 0.84. So if it was 16%, you probably messed up. You probably should have went invert norm 0.16. So let's try invert norm 0.16. Second function in distribution, invert norm 0.16. Now the 16 refers to the shaded area. The 16 refers to, the 0.16 refers to the shaded area. I get a value of 0.994, minus 0.994, minus 0.994. What does that mean in terms of the picture? Draw the picture. There's the mean. I'm always shading from left. What percent am I shading? It's whatever's in the bracket. So in this case, 16%. How far do I go to get 16%? Not very far, right? Not very far. Just a little bit, maybe to about there. What is the cutoff? What's the Z-score that cuts off 16% from the left? Minus 0.994. That's the Z-score that cuts that off. Okay? I haven't given you any concrete examples, but that's basically how it works. And then once you've got that Z-score, then you can go X minus mu, and you can solve for any one of those four things, right? If you've got the Z-score, you can solve for the X, you can solve for the mean, you can solve for the standard deviation. Okay? Let me give you an example. Here's a crazy example. Mr. Bennett makes a test so that 25% of students will fail. Kind of stupid, isn't it?
Yes.
They used to do this in college back in the 70s. They made the test so a certain number of kids would fail. Pretty stupid. Anyways, there's other examples, but this is a good one. Mr. Bennett makes a test so that 25% of students will fail. Not going to happen. The average mark is 60 with a standard deviation of 5. So if I say, regardless of what happens, the bottom 25% of you fail. What a crazy idea. What is the lowest possible passing mark? Is this a shade norm or is this an invert norm? I'm giving you the percent. I'm giving you the percent. I'm asking for the lowest possible passing mark. In fact, I'm actually asking you for the raw score. I'm asking for the value of X. What's the lowest possible passing mark? It's not 50, by the way. Okay, so draw a picture. For invert norm, you have to draw pictures. What percent am I shading? Now, you got to be careful with mark kind of questions because the marks are percent as well as the percent of marks, the area. So which one of those percentages is what I'm shading? He makes a test so that 25% of students will fail. The average is 60. So where would I put the 60 on there? In, the average is 60. The middle. Very good, Luke. Right? That one's the 60. The standard deviation is 5, right? The standard deviation. This is my mu. This is my standard deviation, 5%. So what am I shading? The 25%. I'm shading 25%. The bottom 25%. We always shade from the left. So in other words, if I start shading and stop at 25%, these poor individuals over here on the left, guess what? Doesn't matter how good they got. They're in the bottom 25%, they fail. Tough luck.
What if they did that?
There'd be a lot of angry people. But I know.
It's like you can score 70 on your test, but as long as
As long as you're in the, yeah.
always have
There was a time when people actually believed this nonsense, that it was a way of it didn't matter how easy the test was. If it was a real easy test, then that sort of negated the fact that it was easy, and the bottom 25% should still fail. We wouldn't do this nowadays, of course, but you might do this if you're like doing like quality control. Like if you want your bottom 25% of ball bearings or bags of chips or whatever, right? You want to make sure that no more than 25% fail. You want to know what that cutoff is, right? For whatever purpose that is that you're doing it for. So in other words, the bottom 25% is my shaded area here. I'm trying to solve for my corresponding Z-score. So what do I plug in? I go invert norm, and I didn't spell that very well. Invert norm 0.25, and what do you get? Negative 0.675. Okay, that seems about right, right? It's got to be negative. It's got to be below. It's not too far down. Minus 0.675. But the question is, what is the lowest possible passing mark? Not the lowest possible z-score, right? This is a z-score. How do I convert z-scores to raw scores? Same way we converted raw scores to z-scores. The formula, z equals x minus mu all over sigma. What's the z-score I'm trying to convert? Minus 0.675. What am I solving for? The raw score, x. What's my mu value? Now, should I use 60 or should I use 0.6?
0.6. I'm wrong.
Actually, the answer is it doesn't matter. As long as, if you put 0.6, your standard deviation has to be 0.05. Okay, so either will work. You can put minus 60 over 5, or if you want, you could go minus 0.60, but you have to go all over 0.05. Either one of those is fine. I like the whole number one. I'm sure you guys do too. How do you solve that little equation? Now here's where, and I know applied math students tend to be ones that didn't do very well in algebra, so this kind of thing can be a bit of a challenge. How do you solve that, Luke? Yeah, but it's always going to be multiplied by the bottom number, right? Oh, I want that a different color. Actually, if I do it like this, I'm good. Take the 5, because it's divide by, the 5 goes up there and becomes a multiply, right? To get rid of a divide by 5, you multiply by 5. And then to get rid of minus 60, you add 60. So it's always going to be x minus 60, 5 times minus oops, not 1. 5 times minus 0.675. We're almost there. And then I take this minus 60 and do what? Add it to the other side. So it's going to be 60 plus 5 times 0.675. I know it's hard. So I'm going to go 5 times, now that's minus 0.675, isn't it? 5 times negative 0.675, and I'm going to add that to 60. And that tells me that the lowest possible passing mark is 56.6.
Wouldn't it change if you use 0.6?
It would give you 0.566. That's all. Yeah. Okay. I know that's probably not the best example. I know it's a bit of a challenge. Don't worry about it too much. I have hardly ever seen an invert norm question on the exam. Hardly ever. But on the very off chance that it comes up. Okay? So this tells me that if I say everybody fails if you get less than 56.6, what percent of kids should fail? 25%. So do you see how it's the opposite of shade norm? Does that sort of kind of make sense? Sort of kind of? Okay. Now where we see this is, and I don't know, have every guys ever done fitness testing? In the good old days when I was a kid and they had like the flex arm hang and all that stuff, they had fitness testing and then they ranked you at percentiles. Okay? Have you ever seen people at a percentile? No? Okay. If you were at what's called the 80th percentile for your age, like let's say you're doing the 400-meter run or something like that, if you're at the 80th percentile, it means that you are bigger, better, faster, taller, smarter, whatever it is, than 80% of the population. If you're at the 80th percentile, 80% of the people are below you on the curve. If you're at the 90th, then you are better than 90% of the population. If you are at the 100th percentile, you are the best person in the world. If you're at the 100th. Okay? If you're at the 80th percentile, you are in the top 20%. Okay? So if you were to draw a picture, 80th percentile, how far do I have to shade? I got to shade all the way to 80%. And the Z-score right there. Okay? They would use this like if they're trying to figure out who should be going to the Olympics, stuff like that. They want to make sure that only the top 5% of all athletes are at the Olympics, so they set the standard so that they find out what the Z score would be for the 90th percentile or whatever it is that they decide is the cutoff. And then that's how they would do that. Okay? Okay? Now, you do have another handout. Do I need to go back to that? You do have another handout here because I'm afraid I do have to go. You should have all of these three right here. Okay? And let me just explain what all three of these pages are. I'm just going to go over here so the microphone can hear me. Okay? You should have this sheet here, old exam questions. Okay? I neglected to hand that out yesterday. These are old shade norm kind of questions from the exam. Okay? So you can work on those. Here's a handout that I made. The first three examples are shade norm questions. I've done the solution for you. These are examples. If you're still struggling with shade norm, here's some examples. What I would recommend you do, in fact, we did the first one already. You could cover up the solution, try it, and then see how you did. The solution's right there. Okay, that's a great way to study. Flip it over, the Flat Tire Corporation. Okay, cover up the answer, look at the solution. Example number 3, same thing, cover up the solution, try it, look at the answer. Examples number 4 and 5 are invert norm questions. They are examples. All of these are examples. If you do them, cover up the solution, check how you did, okay? It's a great way to look at things. Good question. Let me finish. The third handout, these are all invert norm questions. There's 6 invert norm questions. I did full out hand-drawn solutions for you. There's no reason for you to say, I don't know how to do it. Okay? If all you do is copy out the solution, you will still learn something. If you copied out 5 solutions, by the time you got to the 6th one, you'd say, oh, I know how to do this. Okay? If you're really serious about learning how to do invert norm. Janelle wants to know when the test is. I still need to cover, in the book, I still need to cover 3.5, which is the normal approximation to the binomial distribution. Okay, I need to cover that. That will be Monday. Tuesday, confidence intervals. I'm confident you'll like that. Actually, I'm confident that you won't. Okay, and that is it. So that means we could possibly have the test Wednesday, although I think that's a bit of a stretch, don't you? Should we go with Thursday? Yeah, I know. I know. Let's aim for Thursday, shall we?
Sure.
I think we'll aim for Thursday. Okay? Aim for Thursday. Remember, there's no school tomorrow. If you don't have the stats project, the one about the cows, you should probably get it.
When's that due?
Can we say Friday as well?